in the previous video, we have taken the introduction, first two steps of this question. Now here, coming to the next part, now we need to tabulate the column. For section 1 and 2, we take minus j infinity, minus j0, plus j0 and plus j infinity as the omega value. So for these omega values, we have to tabulate the real, imaginary, magnitude and angle of the g of omega, h of omega function. Okay, so the real part is minus 4 by 1 plus omega square, minus 4 divided by 1 plus omega square, and imaginary part is minus omega divided by 1 plus omega square. Now these two can be obtained when you rationalize this function. Okay, the angle is equal to tan inverse omega by 4 minus tan inverse omega by 1 minus tan inverse of omega by minus 1. Now this tan inverse of omega by minus 1, this will be equal to tan inverse minus omega. So tan inverse minus omega should be taken as 180 degree minus tan inverse omega. So this will give you the accurate angle. Okay, so when you substitute 180 degree minus tan inverse omega in this expression, this is your final expression. So this tan inverse omega gets cancelled, and what remains is minus 180 degree tan inverse omega by 4. So now we will tabulate it. Okay, so first we will take when omega tends to minus infinity. So the real part is equal to limit omega tends to minus infinity minus 4 divided by 1 plus omega square. So this is equal to minus 4 divided by 1 plus minus infinity square, which is equal to minus 4 by infinity square, because infinity square is much larger compared to 1. Minus infinity whole square is infinity square. So this is large, so 1 can be ignored. So this is equal to minus 0, because 4 by infinity is 0. This minus sign will be there no matter whatever value of infinity you take. Similarly, imaginary part is equal to limit omega tends to minus infinity minus omega divided by 1 plus omega square. So minus of minus infinity divided by 1 plus omega square, 1 can be ignored. So minus infinity the whole square. So this becomes plus infinity by infinity whole square. This gets cancelled, this gets cancelled. So remaining is 0. So you will have minus 0 and 0. Next, coming to the angle, minus 180 degree plus tan inverse of minus infinity by 4. So this is equal to minus 180 degree plus tan inverse of minus infinity. So this minus sign taken outside, 180 degree minus tan inverse infinity. This is equal to minus 180 degree minus 90 degree, which is equal to minus 270 degree. Okay, or this is equal to minus 90 degree. So here the angle is plus minus 270 or plus 90 degree. So the magnitude of this and this will be 0. So similarly, when omega tends to minus 0, so your real part is minus 4 divided by 1 plus minus 0 the whole square. So this is equal to, this 0 becomes very small. So minus 4 by 1, which is equal to minus 4. So imaginary part is minus of minus 0 divided by 1 plus minus 0 the whole square, which is equal to 0. So this is minus 4, this is 0, this becomes 4, and angle is minus 180 degree minus tan inverse of minus 0. So this is minus 180 degree. So this is here minus 180 degrees. Okay, next when omega tends to 0, so the real part is minus 4 divided by 1 plus 0 square, again which is equal to minus 4. Imaginary part is minus of 0 divided by 1 plus 0 square. This is equal to minus 0. And angle is 180 minus tan inverse of 0. This is equal to minus 180. So here it is minus 4, 0, 4 and minus 180. Next, when omega tends to plus infinity, so the real part is minus 4 divided by 1 plus infinity square. So minus 4 by infinity square, this is minus 0. Then the imaginary part is minus of infinity divided by 1 plus infinity square. So this is minus infinity divided by infinity square, 1 by minus infinity, which is equal to minus 0. So this is, sorry, even this has to be minus 0 and this is minus 0. And angle is minus 180 minus tan inverse of infinity. So minus 180 minus 90, sorry, minus 180 plus tan inverse infinity. So minus 180, so even this has to be plus, this is plus, yeah, okay. So this is minus 180 plus 90. So this is minus 90. So this angle is minus 90 degrees and this is 0. So now we will try to draw the Nyquist plot, the section 1 and section 2 of the Nyquist plot using this information. Okay, whatever we have tabulated, using that we will draw the Nyquist plot. So coming to the Nyquist plot for section 1 and section 2, here this is the starting point of section 1. This is the ending point of section 1. Okay, here section 1. This is the starting point of section 1. This is the ending point of section 2 and ending point of section 2. So first I will mark the points. So this is 1 point. This is second point. So minus 4 plus j0. So this is 0 plus j0, minus 4 plus j0, minus 4 plus j0, 0 and 0. Here you can see that your real part, no matter what, will always be negative. Okay, so and the imaginary part for section 1 it is positive and for section 2 it is negative, which means that section 1 will be in the second quadrant and section 2 will be in the third quadrant. So how did we make this? Because looking at this sign. So here real is negative, imaginary is positive. Real is negative, imaginary is positive. This can happen only in the second quadrant. Here both are negative, which is possible only in the third quadrant. Okay, so now the Nyquist plot of this. This is the starting point. So when omega tends to minus infinity, so it starts from here, ends here. So this is the direction of the Nyquist plot. Okay, this is when omega tends to minus 0. Next, when omega is plus 0, this is the same point. So it will start from here and its origin is the ending point. So this is the ending point. So this is how your direction will be. Okay, so this is when omega tends to plus 0 and this is when omega tends to plus infinity. So now this is for, this map is for section 1, this is for section 2, but now we still have section 3 remaining. Okay, so in the next video we will look into section 3 plotting. Thank you.